This is Lesson 8, Comparing Relationships with Equations, and this is Activity 2, More Conversions. And a conversion is, once again, when you change from one kind of unit to another unit, another type of unit, to measure the same thing. So for example, in this case, to measure the same temperature, you can either measure that temperature in degrees Celsius or degrees Fahrenheit. So this is changing from degrees Celsius to degrees Fahrenheit. The temperature is still the same. It's just the units that you measure it in are different. Just like you can measure the same length in inches or in centimeters. So this equation changes or converts the number of inches that you have to the same, or to the number of centimeters to measure that same distance. And in several cases, I'm going to go through the calculation in some detail. So you can just skip over those places if you want. But I think it's useful to see how to do those calculations without always grabbing a calculator. So the first table, changing degrees Celsius to degrees Fahrenheit. And one thing to note is that degrees Fahrenheit are bigger. It's a bigger amount. So actually the size of a degree Fahrenheit is actually smaller. You need more of them to measure the same temperature. So you need more degrees Fahrenheit than degrees Celsius to measure the same temperature. So just a quick example here. If it's 20 degrees Celsius, then it's 68 degrees Fahrenheit. So a degree Fahrenheit is smaller. You need more of them to measure that same temperature. All right, to do the conversion, plug in 24 degrees Celsius up here, 20 times 9/5, and then you add 32 degrees to that. So notice in every case, you're going to do the calculation with the degrees Celsius. You're going to multiply that by 9/5, and then you're going to add 32 degrees more to that. So 9/5 times 20. I would factor the 20 into 4 times 5, and then times that 9. The 5s can cancel out. So now you get 9 times 4 is 36. You add that to 32 degrees, and you end up with 68 degrees. So these are the same temperatures. This is just that same temperature measured in Celsius, and that same temperature, by the same temperature, I mean the same amount of heat measured in 68 degrees. All right, 4 degrees Celsius. So this is 9/5 times 4, and then you're going to add 32 to that. So 9 times 4 is 36/5 plus 32. Well, that's a little bit tougher in that, think about what you can divide, what number you can divide 5 by to get a whole number. And one of those choices is 35. So 35 divided by 5 is 7. So that leaves 1/5 left over. So you use 35 of these fifths to make 7, 1/5 left over. Add these all together. So 7 plus 32 is 39. And then that 1/5 is 39 and 1/5 degrees Fahrenheit. 175 degrees. So 9/5 times 175 plus 32. Now this is a little bit tougher. What can you break 175 degrees up into so that you can divide it by 5? Now any number that ends in 5 or 0 is a multiple of 5, meaning it could be divided by 5. And you might think about, just pick some numbers that you know 150. So 5 times 30 equals 150. That leaves 25 left over. So 30 plus 25 divided by 5 is 5. So 30 plus that 5 is going to give you 35. This is a little bit tougher. You might write it out. Think about it after you write it out. So 9 times 35 times 5. These 5s cancel. So 9 times 35. So I just wrote that here. Broke that up a little bit. So 9 times 30 plus 5. So 9 times 30 is 270. 9 times 5 is 45. This is going to give you an answer of 270 plus 45 plus that 32. And I left it this way instead of adding these two numbers together because I looked at this 32 and realize that could be added to 270. That makes 302. That's pretty easy to do. Then add 45 to that, so it's 347. So again, going into the calculations in some detail, just to give students a sense of how you can work with these numbers without always grabbing a calculator. It helps you understand the calculation or what's going on if you try to do it mentally or on a piece of paper. All right, so how many degrees Fahrenheit are there per 1 unit degree Celsius? So per unit degree Celsius, the number of degrees Fahrenheit per unit degree Celsius. So you're going to take the degrees Fahrenheit and divide it by the degrees Celsius. So I'm going to start out with 39 1/5 divided by 4. And that's the same as 1/4 times 39 plus 1/5. So I'm starting to look at this. How can I do this mentally? I'm going to go to the next page. I zoomed in on this. So I'm going to look at that 39 as 36 plus 3. So because I know that 1/4 of 36 is 9, that's this 9 right here, and 1/4 of 3 is 3/4. So 1/4 of 39 is 9 3/4. So you might look at that several times, think about it. And what you have left over then is 1/4 times 1/5. So this 1/4 times 39 is 9 3/4, and this 1/4 times this 1/5 is 1/20. Now this is the distributive property, using the distributive property to figure out 1/4 times 39 and 1/5. 1/4 times 1/5 is 1/20. So now you have 9 and 15/20. You have to change this to 20ths so you can add these two together. 5 times 3 is 15. 5 times 4 is 20. So this is 15/20. Add them together, you get 9 and 16/20. And now this can be simplified. 16/20 is the same as 4/5. 16 divided by 4 is 4. 20 divided by 4 is 5. And 4/5 is the same as 9 8/10. 2 times 4 is 8. 2 times 5 is 10. That's 8/10. Write it as a decimal, 8/10. So just this little calculation, there's a lot going on. If you go through it a couple times, look at it back and forth, try it on your own, then look at what I did, try it again on your own, look at what I did. Eventually you will understand how to do this. All right, the next calculation is 68 degrees divided by 20 degrees. 68 divided by 20, so I'm going to zoom in on this one. 68 divided by 20. You might just look at this right away and realize, well, 68 divided by 2, that's not too bad, that's 34. And then 34 divided by 10 is 3 4/10. You might very quickly be able to see that. Or you could do it another way. Look at what you can divide by 20 without any remainder or equally or evenly. 60 divided by 20 is 3. And then you have 8/20 left over. Well, 60 divided by 20 plus 8/20, factor out the 4s. 4 times 2, 4 times 5, those 4s cancel. So that's 3 2/5. So this 3 comes from the 60 divided by 20, 2/5, and 2/5 is the same as 4/10. 4, 2 times 2 is 4, 2 times 5 is 10, that's 4/10. And you might get the 4/10 from here as well. 8/20 is the same as 4/10 also. All right, so 3 4/10. And the last one, I did just use a calculator for the last one. No, I couldn't see any easy way to do that. And if I thought about it hard enough, I could see the 1 certainly, but it gets to a point where, yeah, it's easier to use a calculator. So 347 over 175 is 1 98/100. Now, one of the things I want you to notice is that if you write these degrees Celsius in order, 4 increasing, so 4, 20, and then 175, you're going to notice that the number of degrees Fahrenheit increases, 39, 68, and 347, and then that ratio actually decreases. So it goes from 9 8/10 to 3 4/10 to 1 98/100. And I'm going to come back to that. So down on this next page, this is the next table. We're going to go through this, but at the bottom of that table, I wrote those 3 temperatures in order, 4, 20, and 175. So here's the 4, 20, 175. And here's the ratio of the number of degrees Fahrenheit to a degree Celsius. So this is 9 8/10 per degree Celsius, 3 4/10 per degree Celsius, and 1 98/100 per degree Celsius. You can see that this decreases, and this is going to approach 1 8/10, meaning it's going to move smaller and smaller and smaller as this temperature gets hotter and hotter and hotter, and eventually it will become close to, will never reach, but it will become close to 1 8/10. We're going to take a look at that. That's a little bit higher level mathematics, but it's here. We might as well take a look at what's going on. But first, let's look at changing inches to centimeters. Now, centimeters are smaller than inches. So in this case, this is similar to the last table in which a degree Fahrenheit was smaller than a degree Celsius. So you're going to need more centimeters to measure the same distance. And you're going to need 2 5400 times more centimeters to measure the same distance, so per inch. So 2 5400 times per inch is going to give you the number of centimeters, because you need more centimeters to measure that same distance. All right, so if the length is 10 inches, how many centimeters is that? It's 10 times 2 5400, which is 25 4/10. So you might notice that these digits are all the same, 254, 254. It's just that the digits has slid over one place value to the left, or one place value larger, because you're multiplying by 10. If the number of inches is 8 inches, it's 2 5400 times 8. I didn't zoom in on that one. So 8 times 2 is 16. So again, I just broke it up. How can you do this relatively easily in your head? Well, 8 times 2 is 16. 8 times 5 is 40. So 8 times 5/10 is 4. And 8 times 4 hundredths is 32 hundredths. 8 times 4 is 32, 32 hundredths. Add all these together, you get 20 32 hundredths centimeters. And finally, I did zoom in on this one. This is 2 5400 times 3, and I'm going to use the distributive property. I'm going to treat it as 2 5400 times 3 plus 1/2. So 3 times 2 5400 plus 1/2 times 2 5400. That's using the distributive property. All right, this gets a little bit, it's only complicated because there's a lot of small pieces. But you can do every small part of this, and then you just add everything together. Everybody knows what 3 times 2 is. That's the 6 right here. 3 times 5 is 15. This is 3 times 5/10 is 15/10, or 1 5/10. And 3 times 4 hundredths is 12 hundredths. So these three numbers aren't too bad. And then the halves. Half of 2 is 1. 1/2 of 2 is 1. 1/2 of 50 cents, or 50 hundredths, is 25 hundredths. And 1/2 of 4 hundredths is 2 hundredths. Then add everything together. Well, this is 6, 7, 8 and a half. This is 8 1/2 right here. So once again, 6, 7, 8 and 1/2. And then 25, 35 for that 10 right there. 36, 37, 38, 39. So 25 hundredths plus 10 hundredths plus 2 hundredths plus 2 hundredths. So 25, 35, 36, 37, 38, 39. And 5/10 plus 3/10, and then 9 hundredths is that 89 hundredths right here. So you get an answer of 8 89 hundredths. So what's the number of centimeters per 1 inch? How many centimeters do you get for 1 inch? And that answer is 2 5400 centimeters. So you get 2 5400 centimeters, 10 inches, 25 4/10 centimeters. The next one, 20 32 hundredths divided by 8. I broke this up into 16 because I'm divided by 8, can see that 16 divided by 8, that's pretty easy, that's 2. That leaves me with 4. 4 divided by 8 is 1/2 or 5/10, and that leaves me with 32 hundredths. Well, 32 hundredths divided by 8 is 4. That's the opposite of what we did over here. So these are just the opposite, the calculation in the opposite direction. Dividing by 8, over here you're multiplying by 8. And actually that's okay. All right, and finally, 3.5 times, 8 89 hundredths divided by 3.5. And I did zoom in on this one a little bit. One of the points I try to get across throughout these lessons is to keep things as fractions. Keep working with fractions until you just can't do it anymore, because you might reach a point where you just have to use a calculator to do the final calculation. But many times you can get pretty far just keeping it as a fraction. So if you keep this 3 1/2 as 7/2, so 8 89 hundredths divided by 7/2. Well, that's, how do you calculate that? You multiply this value, 8 and 89 hundredths. So you're going to change the operation from division to multiplication. 8 and 89 hundredths times. You're going to use the inverse operation, and you're going to use the multiplicative inverse, which is 2/7. So 8 and 89 hundredths times 2/7. And this is not too bad now to calculate. It's just multiplying each of these digits by 2. 2 times 8 is 16. 2 times 8 is 16, but 16 tenths. And 2 times 9 is 18 hundredths. A little bit harder to add together, maybe, I don't know, 16 plus 1 is 17, and 6 tenths, 7 tenths, that's not too bad, 7 tenths and 8 hundredths, so that's 17 and 78 hundredths. And that divided by 7, that can be a little bit tough, but recognize that 14 divided by 7 is 2. So if I take out the 14, I'm left with 3 and 78 hundredths. Well, this is 37 and then an 8. Well, I know that 35 divided by 7 is 5. So I'm going to take 35. Remember that this 7 now has become a 3 because you subtracted 14. So I'm looking at this, it's 37. I'm looking at it as 35 divided by 7. Is that 5? And then how many do you have left over? You have 28 hundredths left over. So 28 hundredths divided by 7 is that 4. So you might try to do that on pencil, using a pencil and paper, working it out, see if you get the right answer. Just practice. All right, so we've gone through all these calculations, and we have shown that, are these proportional relationships? Explain why or why not. Well, the conversion to degrees Fahrenheit is not a proportional relationship, because there is no single value for the number of degrees Fahrenheit per single degree Celsius. That changes. As the degrees Celsius changes, this ratio changes. It's not constant. So since it changes, and that's this ratio right here, since this changes, it is not a proportional relationship. It doesn't change. If you double the degrees Celsius, the degrees Fahrenheit doesn't double. It has a value other than doubling. And you're going to see what happens as the degrees Celsius increases, gets hotter and hotter and hotter. What happens to this ratio is that this decreases and it approaches 1 8/10. I'm going to go over that in just a second. But the conversion of inches to centimeters is a proportional relationship. Every single time you get an answer that the number of centimeters per 1 inch is always 2 54 hundredths. That's what this tells you. So this is constant. It's a constant amount. So it is proportional. If you double the number of inches, you're going to double the number of centimeters. So this is 2 54 hundredths per 1 inch. If you multiply this 1 inch times 10 inches, you're going to multiply 2 54 hundredths times 10 to get 24 4/10 centimeters. So this is moves together, these two properties, length or centimeters, move together through multiplication to always get a ratio of 2 54 centimeters per 1 inch. All right, so let's take a look at what's going on here. This will approach 1 8/10 as the temperature gets hotter and hotter and hotter, and the question is why? So if we go back to this formula right here, notice that 9/5 is 18/10. 2 times 9 is 18, 2 times 5 is 10, so that's 18/10. That's this 1 8/10. So why do you think it approaches this 1 8/10? And so notice, if you got rid of this 32, that's what it would be. The degrees Fahrenheit divided by the degrees Celsius would be that 1 8/10. But what makes it different than that is you're always adding this 32 regardless of this calculation. So what happens if you make this part of the equation really, really big? In other words, the degrees Celsius really, really high or really, really hot. I don't know if this makes sense to you or not. I just thought I would try it. So on this rectangle on the left here, I'm showing the increase in the degrees Celsius as the size of this dot. As this gets larger and larger and larger, imagine that it's getting hotter and hotter and hotter. So to change this to degrees Fahrenheit, what do? Well, you multiply this degrees Celsius almost by 2. 1 8/10 is very close to 2. So what I did here is I just overlapped these dots just a tiny bit to show you that it's supposed to be a little bit less than 2. It's supposed to be about 1 8/10. And then what do you do every single time? You add 32 degrees. Now notice what's happening to the size of this calculation right here. This 1 8/10 times the degrees Celsius. This is getting really, really big, but this is staying the same size. And if you increase it to a value that is really, really hot, this barely adds anything. So this essentially becomes that 1 8/10. So that's why that calculation is approaching 1 8/10, because it's like making this calculation 1 8/10 times degrees Celsius and getting a huge amount. So if this is the degrees Celsius, then if you just a little bit less than doubling that, you make this a huge amount, then you add just a tiny bit to that, 32 degrees. It's like saying, this isn't going to change it very much. So really, in essence, you have this value. I don't know if that makes sense, but that's what's happening. This is a higher level mathematics that we're doing. I'm just trying to visually show you what it is. It is like saying, I'm going to give you $1. I'm going to double that $1, give you $2. I'm going to add $32 to that. Well, I'm going to increase the amount that I give you. I'm going to double it, but I'm always going to add $32 to that. Let's say you get up to here where you're going to give somebody $1 million. I'm going to give you $1 million. You're going to double that to $2 million. And then I'm going to go back and give you another $32. Well, that $32, if you have $1 million and then $2 million, you're not going to care about that $32. That's essentially adding nothing. So it's just the visual example of what's going on. You're adding a constant amount, and this is increasing larger and larger and larger, so making that constant amount, that this amount contributes to the total, almost insignificant when you get to really high numbers.